Good day everyone. Welcome to Teacher Julie channel. Hello everyone. We have our new lesson in Earth and Life Science, which is all about the rock metamorphism. This will be the first quarter topic and week 2. This lesson is under the milk-based. The word metamorphism comes from the Greek word meta, which means after, and more, which means form. So metamorphism means the after form. Metamorphism is the change that takes place within the body of rock as the result of being subjected to conditions that are different from those in which it formed. It is also defined as the mineralogical and structural adjustment of rocks to physical and chemical conditions that have been imposed at depth below the near surface zone of weathering. In geology, this refers to the changes in minerals, assemblage, and texture that result from subjecting a rock to conditions such as pressure, temperature, and chemical environment different from those under which rock originally formed. Metamorphism therefore occurs at temperatures and pressure higher than 200 degrees Celsius. Rocks can be subjected to this higher temperature and pressure as they are buried deeper in the earth. Such burial usually takes place as a result of tectonic processes such as continental collision or subduction. Low-grade metamorphism takes place at temperatures between about 200 to 320 degrees Celsius and relatively low pressure. Low-grade metamorphic rocks are generally characterized by an abundance of hydrous minerals. With the increasing grade of metamorphism, the hydrous minerals begin to react with other minerals and/or break down to less the hydrous minerals. High-grade metamorphism takes place at temperatures greater than 320 degrees Celsius and relatively high pressure. As the grade of metamorphism increases, hydrous minerals become less hydrous by losing the H2O, and non-hydrous minerals become more common. The following are the types of metamorphism. The first one is the contact metamorphism. It is occur adjacent to the igneous intrusions and result from high temperature associated with the igneous intrusion. Because the temperature contrast between the surrounding rock and the intruded magma is larger at shallow levels in the crust where pressure is low, and contact metamorphism is often referred to as high temperature and low pressure metamorphism. The rock produced is often a fine-grained rock that shows no foliation, called a hornfills. Another types of metamorphism is the regional metamorphism. It occurs over large areas and generally does not show any relationship to igneous bodies. It is usually results in forming metamorphic rocks that are strongly foliated. The differential stress usually result from tectonic forces that produce compressional stresses in the rocks, such as when two continental masses collide. Thus, regionally metamorphosed rocks occur in the course of fold, thrust mountain belt, or eroded mountain ranges. Compressive stresses result in the folding of rocks and the thickening of the crust, which tends to push rocks to deeper levels where they are subjected to higher temperatures and pressures. Another types of metamorphism is the cataclastic metamorphism. It occurs as the result of mechanical deformation, like when two bodies of rock slide past each other, another along a fault zone. Heat is generated by the friction of sliding along such as shear zone, and the rocks tend to be mechanically deformed, being crushed and pulverized due to the shearing. Cataclysmic metamorphism is not very common and is restricted to a narrow zone along which the shearing occurred. Another types of metamorphism is the hydrothermal metamorphism. Rocks that are altered at high temperatures and moderate pressures by hydrothermal fluids are hydrothermally metamorphosed. This is common in basaltic rocks that generally lack hydrous minerals. The hydrothermal metamorphism results in the alteration of such magnesium and Fe-rich hydrous minerals as talc, chlorite, serpentine, austenolite, tremolite, zeolites, and clay minerals. Rich ore deposits are often formed as the result of hydrothermal metamorphism. Another types of metamorphism is the boreal metamorphism. When sedimentary rocks are buried to the depths of several kilometers, temperature greater than 300 degrees Celsius may develop in the absence of differential stress. New mineral grow, but the rock does not appear to be metamorphosed. The main mineral produced are often as the zeolites. Boreal metamorphism overlaps to some extent with diagenesis and grades into regional metamorphism as temperature and pressure increases. Another types of metamorphism is the shock metamorphism or the impact metamorphism. When an extraterrestrial body such as meteorite or comet impact the Earth, or if they are very large volcanic explosion, ultra-high pressure can be generated in the impacted rock. This ultra-high pressure can produce minerals that are only stable at a very high pressure.